Okay, now we are in the introduction to linear functions. So in the last video I went over how do we interpret a Cartesian plane, basically. How do we understand the Cartesian plane? In this video, now we're going to use that Cartesian plane in order to actually draw our functions. So what is a linear function? If we were to draw a Cartesian plane, because we first need a Cartesian plane before we can actually draw our functions in this case. Because we need axes to actually use in order to get certain values to actually produce that graph. That is what we do with functions in this case. So right now we're going to draw a Cartesian plane like this, where we have the y-axis, which is the vertical axis over here, and the x-axis, which is also going to be the horizontal axis. And then we also have this middle of the point over here, which is just our origin point in that case. I'm just going to introduce it. So in the last video, I actually said that the linear function, that was also out of nowhere because I actually wanted to first introduce Cartesian plane. The linear function just means the straight line. So I'm just going to write it here. It just means a straight line function, basically. That's what a linear function actually stands for. A straight line function. Okay, before I show you how to start drawing them, or how to start like using coordinates in order to draw them, I want to just introduce you to some concepts that we need to know when it comes to linear functions. So what is a linear function, right? When I said straight lines, if you can remember from what a straight line is that it is just a line that goes in a straight line. Basically, that's all it is. There's nothing too difficult about that definition there. So I'm gonna draw I'm just gonna do it in a different color because I think that's probably be better. So let me do it in red over here. So I'm gonna draw a straight line over here that goes past the origin. And then I'm going to draw my arrow over them. Remember what I told you about the arrows over here? This arrow just means it's continuous in that case. So it keeps going in the same direction that the arrow points towards, basically. That is exactly what the arrow means. So obviously this is a random straight line, but a few concepts that I wanted to get used to is the equation. What do we know about the equation of the straight line? So our equation of a straight line is the following. We have it as y is equal to m times x plus c. That is our equation of a straight line. And we need to now break them up into parts over here. Now, with the first thing we are going to be looking at, right, is going to be the y. The y and the x have a relationship, obviously, in the function of in the linear function or in any type of function. For the rest of the functional equations, you're actually going to be seeing y and x all the time. But if you are in grade 10, because this is supposed to be grade 9 friendly linear functions, if you're in grade 10, you can clearly see that we are going to be working with f of x in this case. You would see this pop up a lot. This f of x just means the function of x. Obviously, you can write it in the functions introduction video. You could also write it as g of x. But right now, we're not going to be focusing on this right now because I want to make it's just disappearing. We're not going to be focusing on that because this is supposed to be grade 9 friendly in this case. And then once we move to the parabola, which is the next function, that's going to be where it's strictly grade 10 work. So let's move on to y and x. Why do we mention y and x? Y is essentially just any output. So y is obviously represented as the output, right? We can see that the variable y is equal to this entire equation over here. So basically this y indicates we need to get this y by actually adding in our x value to give us the output. So we input our x value from the x-axis over here, and then we get our output, which is our y value, which is going to be over here on the y-axis. Or we can do the opposite. We can actually just input the y value into our equation, and then we can get a specific x value. But obviously in that case we have to solve for x in that case, because it's not going to be a very easy way out whenever we are inputting a y value, because obviously we need to manipulate the equation and solve for x in that case, and then we'll get our x coordinate on the x-axis somewhere. But we'll get into more detail with that later on. For now, we're going to be focusing on the rest of the variables in the equation. So the x and the y values are just the input and the output values in this case. We are going to be plugging in certain values to get another certain value basically. Now, what is the m? So let me just do this quickly, get rid of that and that. So what does the m and the c mean? The m and the c, the plus c in that case. And okay, let's do this. So m would actually stand for the gradient. Now, I know why you're probably asking, why doesn't it stand for g then if it's a gradient in this case? Okay, so I'm just gonna like write down the full word over here. This is not just called the gradient. We can actually write this as the slope intercept as well, or the slope of the graph. So I'm gonna say or. So there's two ways you can say it, or the slope. So what the gradient is actually talking about is actually the slope of the function, of the linear function. So if we were to look at this function over here, right, that I drew over here, let's call this y. This as the equation y equals to mx plus c, right, for now. That is how we write down our equations, by the way. In grade 9, when you label your graphs, you have to write it in that form of y equals to mx plus c. Obviously, if you have the m value and the c value, you do write those values down, obviously. But for now, let's look at the gradient of this function over there, right? We can't interpret it yet because I haven't introduced you to what is a negative gradient and a positive gradient. So first of all, let me go there before we do that. But before I can do that, we need to talk about what does the gradient mean. The gradient talks about the slope of the function, meaning this how steep is the slope. So basically, if we were to have, let's say, okay, here's where we actually start with the example, right? If we have a gradient that is actually going to be greater, that is greater than 0, then in this case, we'll have our linear function to be ascending from left to right. That is what you must remember in that case. You can clearly see that it is ascending from left to right. If the gradient is also, you can also interpret this as m greater than 0. This is also written as positive in this case, right? So positive. Then if we were to talk about the gradient, the value being less than 0, then we were to say that in the Cartesian plane, our linear function would be decreasing from left to right. So how we would interpret this is we actually have to, would read from left to right. I'm just trying to find an easy way to teach this to you. So we are not interpreting it as if it was Arabic. We are actually going to be looking at as if it was just like our normal English language or any other language that we read through. So we look at it from left to right. That's how we interpret functions on a Cartesian plane. So once again, if the gradient is positive, or just if the gradient is greater than 0, then it increases from left to right. But if the gradient is less than 0, meaning the gradient is going to be negative, then, let me just do this to also make it like it's true, then it decreases from left to right, basically. So we are reading graphs from left to right. That's going to come in handy when we are going to interpret graphs later on in that case. So let's go back to the linear function. Okay, back to the gradient, right? If we were to look at the gradient over here of this specific line, right? So I'm probably also going to have to include, whoa, that is all of the stuff. Let me just do this quickly, and then that. Okay. Let's act as if the arrow is going to follow, right? If we were to talk about the steepness of the slope, what we can clearly see over here, let's say that this gradient is going to be positive. Obviously, remember what I said? If it increases from left to right, as you can see over here, so it's basically increasing from left to right in that case. That means that it has a positive gradient. So what we can see over here, let's just try and move this gradient around, the slope around, right? So if we were to move the slope like so, right, we are basically making the slope steeper and steeper and steeper, meaning that the gradient of the slope is constantly increasing in this case. And obviously, if we were to move it in the opposite direction like so, it will be decreasing, but it'll still be positive in this case, right? And then we keep moving it down and down and down until we reach a flat line. Now, this is the part where things change, right? That there's no longer a slope. You can clearly see that it is in line with the x-axis. Or if you will, this is actually parallel to the x-axis. Can you see? So that is actually what we need to look at over here. If the gradient is equal to 0, then on the Cartesian plane, this gradient over here will actually just be a flat line. It doesn't matter where you place the line, obviously, as long as this gradient, as long as this line over here is parallel to the x-axis, obviously. That just means that the gradient is equal to 0 in that case, right? Now if we were to go back over here to this graph, that is where the gradient is equal to 0, when it is a flat line. But what if we were to keep moving it in this direction? Oh, now we can see it, we have something different here. So, from where the gradient is equal to 0, we can clearly see that we went from the positive numbers and we reached 0. Now we're going back, now we keep going and we reach the negative side. And that is exactly why I say that the gradient is negative when it decreases from left to right, basically. So you can clearly see that this decreases from left to right in this case. And that is why we have a negative gradient in that case. So once again, just to recap over here, if we have a line like this that's increasing from left to right, it is a positive gradient. And if we have a horizontal gradient, where that means that the gradient is equal to 0 in that case. If we have a horizontal, if the line is parallel to the x-axis, then the gradient will be equal to 0. And if we have this slope where it decreases from left to right, the gradient is actually going to be negative. Now, we dealt with those, right? But what happens if it actually is vertical? What happens if it is in? What happens if it? Okay, I'm just going to be honest. Let's just assume that this over here is parallel to the y-axis in this case, right? So what if it is parallel to the y-axis? Then what? We're just going to simply say the following. This is where we say that the gradient will be undefined. So I'm going to say undef as short, and then obviously let's do our Cartesian plane over here, and we can see that if this this gradient is in line over here, so you can see it's a vertical line over here, and it is parallel to the y-axis over here, therefore the gradient will be undefined. And whenever you have in grade 9 a multiple choice type question where they say which gradient represents which straight line represents the undefined gradient, then you would know that if it is parallel to the y-axis, or if it is a vertical straight line, then the gradient is undefined. But if the gradient over here is equal to 0, then it will be, if the gradient was a horizontal line or parallel to the x-axis, it will be equal to 0 in that case. And this is an introduction to straight lines, but we are not done yet. Now I'm going to finish off with the c value in this case. Remember, we still got one more to go through, and that is the c value. Okay, so what is the c value mean? What does the c value mean? Let me just indicate the arrow here. The c value actually just means the y-intercept in this case. So the y-intercept. That I'm just going to write y-int for short. Now, what do we know about a y-intercept, right? With the y-intercept, let me just go through this right here. The y-intercept is the point that touches the y-axis, if it wasn't so obvious. It's the point that intercepts the y-axis. So if we were to look at this graph over here, right, then we can clearly see that it touches one point only over here, which is going to be the, I don't know why it does that all the time, it is the y is equal to which value? We can see it's touching the origin, and we know that this coordinate set over here for the origin is going to be 0 and 0. So therefore, we know that our y coordinate, which is right over here, that's what it's represented as, the y coordinate is going to be equal to 0 in this case. So that is what a y-intercept means. What if I were to actually just make a new function? So let's say, for example, I were to actually create a new straight line function in this case. So what if I were to do a straight line function that looks something like this, right? So like this. And then obviously I have my arrows here that indicate it's continuous. Now we can see it touches 2 points, which is this point over here and this point over here, right? Let's make it a little bit bigger. Okay, so as we can see, it intercepts with a y on the y-axis over here. So we can see that there's a y value here, and it also intercepts the x-axis, which means that it's an x value over there. Now, if we were to say the following, let's say that let's say this point over here is going to be -1, because obviously we can see it's in the negative, and this one will be +1. X is equal to +1, and therefore this value over here is actually our y-intercept, because it's actually touching the y-axis. Now, how do you write it in coordinate form? If you can remember, if we talk about a point on the y-axis, we know that that x coordinate will be equal to 0, because it's in line with the origin over here, basically, where x is equal to 0. So if it's on, and we also know that on the y-axis, the x value will be equal to 0. So basically what we're trying to say over here, if we're talking about the y-intercept, the x value will be equal to 0. If we talk about the x-intercept, which will come handy later on, then we are going to be talking about not the x value, the y value will be equal to 0. So therefore that coordinate over there will be 0 and -1. That is the y-intercept. And now we obviously can't leave it hanging over here. We have 1 over here, which is just going to be indicating that we have the x value, which is equal to 1 in this case, because remember that's the x value on the Cartesian plane there. And then our y value will be 0, because it is touching the x-axis in that case. So that is so that is how we look at linear functions. That's an introduction. In the next videos on the linear functions, I'm going to be going over the applications. Right now, I was just introducing you to what is a linear function, what is the formula of the linear function, or sorry, the equation of the linear function, and what do the variables mean. So obviously we have the y and the x value, which is just the output and the input values respectively. And we have the m value, which is the gradient, and the c value, which is the y-intercept. Next videos will be on the applications of linear functions.